Intro Algebra Lesson 4-5A. We spent some time dealing with slope and making graphs, and today we're going to talk about something known as a constant of variation. We'll use the letter K to refer to that constant. It's the amount that is increased or decreased by when we use direct variation. Now, to give you an idea of what I mean, let's take, for example, going to the gas station and buying gas. When you go to the gas station, maybe the price per gallon is $3.30 per gallon. So the constant, K, is going to be $3.30 per gallon, because if we buy 5 gallons, it's still going to be $3.30 a gallon. If we buy 10 gallons, it's still going to be $3.30 per gallon. It's not like when they fill up your tank and they have the pump in, they're like, hey, that first gallon was $3.30, but this second gallon is going to be $3.80, and the third gallon is going to be $3.95. It doesn't change. It's constantly the same amount. And that way we can tell over time how much it's going to be that it costs. So the amount increased or decreased by is our constant. If we're using up air in our tank when we go scuba diving at a constant amount, we can figure how long we had to stay underwater and thus do whatever job or exploring that we're doing. So having a constant of variation can be helpful to determine what something might be in the future as in the form of a cost, or in the example I gave of the scuba diving, how long you had to explore. It mentions that this is involved in direct variation. Direct variation is referred to as this formula, y equals kx. There's our k, our constant. So we get an output whenever we take a constant multiplied by an input. Or another variation is y over x is equal to k. If you want to find your constant, take your y and divide by x. Now here's how that worked. If you wanted to get k alone, you'd have to divide by x. What you do to one side, you'd have to do to the other. So the x's would cancel out, and there's your y over x is equal to k. So this is just a variation of the exact same formula, just so it depends on what you're looking for. Remember, if k is positive, then as one value goes up, so will the other. For example, the more gas that I buy, as my amount of gas goes up, so will the total cost. That's because the constant, $3.30 per gallon, is positive. So as one goes up, so does the other. Now, if k is negative, if your constant is negative, then as one goes up, the other will go down. So let's say I'm using the gas now. The longer I drive, as time goes up, the amount of gas in the tank goes down. It decreases. So that would have a constant that is negative. Now, one thing that's interesting about constant, when we looked at graphs and we used the idea of rise over run, we went up and over, up and over, up and over. And this did not change. It was constantly the same slope. It didn't go up 3 over 1, up 3 over 1, up 5 over 1. It would go up the same amount, up 3 over 1, up 3 over 1. Now maybe it would go up 6 over 2, but up 6 over 2 is the same as up 3 over 1, so it's still the same amount, which means slope constantly goes in the same amount from one point to another, which tells us that the slope of y equals kx is k. In other words, m is equal to k. Constant and slope are the same. You might be asked, find the slope of an equation. Or you might be asked, find the constant of an equation. So you look at an equation and it says y equals 7x. It looks to me like the y is in the same spot as y and x is in the same spot as x. So this number right here has to be in the same spot as k. So our constant is 7, which means our slope is also 7. Now you might say, well, slope is rise over run. Okay, you can write 7 as a fraction by putting it over 1. So you now have 7 over 1, rise over run. So slope and constant are the exact same thing. Alright? If you find one, you found the other. Here's an example of any time your constant is greater than 0. And the types of numbers that are greater than 0 are positive. Now this is just one example of the type of graph, but what you'll look at, you read it from left to right, is it's going up. Whenever it's going up, we know that's a positive slope. So positive slope, positive constant. Constant and slope are the same thing, so that would make sense. And the flip of that, if we have one that's going down, then we know that's negative. Anything less than 0 is negative. And as you read this graph from left to right, the slope is going down, so that is a negative slope. We're not going to talk about constants of 0, because then there wouldn't actually be any change. Right? One example, say we were given this equation and we wanted to find the constant of variation. Y equals kx. It sure seems like The 1/4 is the constant. And if we got to find the slope, we know constant is the same as slope. So k equals 1/4 and m equals 1/4. Now we need to make a graph of this. Probably the easiest would be to make an input-output table. So we choose any numbers we want. I would avoid choosing numbers like 1. 1/4 times 1 is easy. It's 1/4. But it's not always easy to graph 1/4. It's not too bad, but it's not great. Choose numbers that 1/4 works well with, like 4, 0, and -4. It's easy to find 1/4 of 4 because it's just 1. It's one chunk of the 4. So that'd be 1. 1/4 of 0 is 0. 1/4 of -4 is -1. We make our graph based on these three coordinates. So we have 4, 1, 0, 0, and -4, -1. And now we have a line that we can draw. And there it is. That graph represents a positive slope because it's going up. Both of these are positive. If you look, it goes up 1 over 4, up 1 over 4. Just like our slope says, up 1 over 4. Constant and slope are the exact same thing.